Hello Math 2 students. Today we're going to graph this quadratic function, but on our way to graphing this quadratic function we're going to answer these four questions. What form is the equation in? What does the form tell you about the graph? How do you find the vertex in this form? And how can you find more points on the graph if you need to? So first of all, we can see that our function has parentheses, but the parentheses are not squared. So this function is in what's called intercept form. So that answers our first question, is we know that it's an intercept form. What does this form, or what does intercept form, tell us about the graph? Well, we know that every x-intercept is going to have a y value of 0. We know that if we put a 0 in for g of x and we solve this side of the equation, we'll have two solutions. And those two solutions will be the x-intercepts. So on our problem, what does this form tell us about the graph? It tells us the x-intercepts. And our x-intercepts are at +1 and +6. So those are our x-intercepts. Then anytime you're graphing a quadratic function, you need to be able to find the vertex. So how do you find the vertex when your graph is in intercept form? Well, the vertex is going to be on the axis of symmetry, which will be exactly in between your two x-intercepts. So that'll be exactly between 1 and 6. So we could count and we could estimate and find out what the exact middle was, but there's a formula that you can use to find the exact middle where the axis of symmetry goes. And that formula is x equals p plus q over 2. And p and q, those are just the letters that represent the two x-intercepts. So if I want to find the x-coordinate of the vertex, I'm going to take 1 plus 6 and divide by 2. And so when I do 1 plus 6, that will be 7 divided by 2. And if you can't do that in your head, it's important to use your calculator, because I've noticed a lot of arithmetic mistakes which are causing people's graphs to come out wrong. So 7 divided by 2 should come out to 3.5. So our vertex is going to be 3.5 comma something. And that something is whatever the y-coordinate is. So in order to find the y-coordinate, we take our original function. So we take, I'm going to use y instead of g of x. I'm going to go y equals -1/2 times x minus 1 times x minus 6. And this is a variable. It was unknown when we started the problem, but after we use this formula, we know that it's 3.5. So it's going to be y equals -1/2 times empty bracket minus 1 times empty bracket minus 6. And I have a feeling that a lot of students aren't writing this down, or they're not typing into their calculator, because this is where there's all kinds of really silly arithmetic mistakes. And the arithmetic we're doing is easy arithmetic involving whole numbers or simple decimals. So we have 3.5, that's our x value, and we have 3.5 here. So we're going to have y equals -1/2 times something times something. And we're going to do the arithmetic that's in the parentheses. Well, 3.5 minus 1 is 2.5. And 3.5 minus 6, if you're not sure what that is, just do it on your calculator. And that comes out to -2.5. And so now we need to multiply -1/2 times 2.5 times -2.5. And it doesn't matter what order you multiply in. Multiplication can happen in any order. So I'm going to multiply 2.5 times -2.5 times -1/2. And that comes out to 3.125. So now we know that our vertex is 3.5, comma 3.125. Now, if we wanted to make an absolute perfect graph, we could use a computer, we could use Desmos, but we're trying to create our own graph. So we're going to have to do a little estimating to find out where those points are. So here is my axis of symmetry, 1, 2, 3, 4. Well, 3.5 is right in the middle between 3 and 4. So I'm going to try to sketch in my axis of symmetry the best I can. That's at x equals 3.5. Now, to finish putting my vertex on the graph, I'm going to have to go up to 3.125. So I'm going to go up to 3 and just a tiny bit above 3. So this would be 1, 2, 3, and a tiny bit above 3 is going to be approximately right there. So my vertex is there at 3.5, comma, 3.125. So now we're going to go to our last question. How can you find more points on the graph if you need to? And so the way you can find more points on the graph is by making a table. And so whenever you need more points than you have, you can make a table. And I realize on this graph we already have 3 points. We can make a pretty accurate picture of our parabola without any more points, but I want to make sure that everyone knows how to use a table because it comes up so much. So we're going to make a table that looks like this. And at this middle point on our table, we're going to put in our vertex. So this is 3.5, comma, 3.125. And I need to make my table symmetrical because I know that my graph is going to be symmetrical. So I want to use whole numbers. So I'm going to start at this 3.5, and I'm going to go up half a space to 4. And I'm going to go down half a space to 3. Now, these are still symmetrical. This is 0.5 away from 4 and 0.5 away from 3. Then I'm going to skip all the way to 5, and I'm going to skip all the way down to 2. So now I have a symmetrical table, and if I find the y values, I'll have more points on my graph. But don't forget, we don't need to do 4 arithmetic problems to fill in these 4 missing y values, because whatever we get for a y value of 4, when x is 3, we'll get the same thing. And when our x is 5, we'll get the same thing as when our x is 2, because we know that a parabola is symmetrical. So now we're going to do a little arithmetic. So I'm going to take my equation, and I'm going to use y instead of g of x. Y equals negative 1/2 times empty bracket minus 1 times empty bracket minus 6. And I'm trying to find the y value, and the x value is 2. So I'm going to put a 2 in here and here. So now I have y equals negative 1/2, and I'm going to have 2 empty brackets. I'm going to do the arithmetic in the parentheses. So 2 take away 1 is 1, and 2 take away 6 is negative 4. So now I can multiply negative 1/2 times 1 times negative 4. And again, if you think you're going to make a mistake, use a calculator. But that comes out to positive 2. So I'm going to have a positive 2 here and a positive 2 there. So I know if I go over 5, I should go up 2. And if I go over 2, I should go up 2. Now I'm going to do one more problem. I'm going to figure out what happens when I put 3 into my equation. So now I have, again, my equation. I'm using y instead of g of x. Y equals negative 1/2 times the x value of 3, trying to find the y value that matches it, minus 1 times 3 minus 6. So I'll have y equals negative 1/2 times 2 times negative 3. And so I'll have negative 1/2 times 2 times negative 3. You can multiply it in any order. You should use a calculator if you think you're going to make a mistake. And that should come out to positive 3. So I'm going to have a 3 here and a 3 here. When I go 3 to the right, I'm going to go up 3. 1, 2, 3, 1, 2, 3. And when I go 4 to the right, I'm also going to go up 3. 1, 2, 3, 4, and up 3. And so my parabola is going to be a smooth curve that looks something like that. So by answering these 4 questions, I was able to create the graph of this function. I knew that the function was in intercept form. I knew the intercept form would tell me the x-intercepts, which were 1 and 6. In order to find the vertex, I had to add up the x-intercepts and divide by 2, and that told me my x value. Then I took that x value and plugged it into the formula to find out the y value, and my vertex was 3.5, 3.125. And then if I needed to find more points on my graph, I needed to use a table. And so I created a table with the vertex in the middle, and I made my table have x coordinates that were symmetrical. And when I put those x coordinates into my function, I found the y values, and now I was able to make an accurate picture of my parabola.